This lecture is going to be on lunar phases. It's going to go over aspects of the Earth, Moon, Sun system. We're going to start off by looking at the lunar phases that are observable. And here I see, let's just make sure we understand what this picture is, because I'm going to be referencing this picture several times. We have sunlight coming from the right, so the sun is kind of off in the distance over here. And you have to pay attention, so we're looking at the sun, and obviously the sunlight. We have to recognize the Earth. Notice the side that is facing the sun is illuminated, right? It's sunlight, photons are striking it, and half of it is dark. It is not being illuminated. So let's follow the moon. We're going to start with just paying attention to what this picture is showing. The pictures on the outside are showing you what the moon would look like from viewing it from Earth. Remember, Earth is here. And these pictures on this particular location are trying to show you the illuminated side. Remember, the illuminated side that's facing the sun is always illuminated. So let's start off with the new moon, and let's go through here. So I want to highlight the first parts. The new moon. We cannot see the new moon. Here's why. Because the side that is illuminated is facing away from the Earth. That we are, quote unquote, seeing the dark side, therefore we are not seeing it. So really the new moon is relatively invisible to us. We don't see it. It's not illuminated. But as it continues to move in its counterclockwise orbit, it begins to be illuminated from the right side. Notice, this is called the waxing crescent. Here we have the first quarter, where half of the right side, well, the right half of the moon is illuminated. Here we have a waxing gibbous, and here we have the full moon. Notice in the phase of the picture at the top, the right-hand side is increasing in illumination, whereas it reaches its full phase, right? The full moon phase. It is fully illuminated. Therefore, the side that is facing Earth is fully illuminated. That's what we see. And the far side is dark. It is not being illuminated. But at this point, it begins to decrease in its illumination, simply based on the location of where the Earth, Moon, Sun are positioned relative to one another. So the right side is being darkened, and therefore it is losing illumination from the right side. So it goes from the full moon. Waning implies it's losing illumination from the right side. Here's a waning gibbous. Here's the third quarter moon. Here's the waning crescent, and it's back to a new moon. And this would constitute one full cycle of lunar phases. Now we're going to go through this. We're going to make sure that we get this. So this is probably worth watching a couple times. Back to the same picture. We're going to go make sure we're going to talk about this a little bit further, a little bit more detail here. So the new moon phase to the full moon phase. We'll just call this top picture, top half of the picture here. This is what we'll focus on the first part here. The new moon phase, as I observe it from the Earth. So I'm standing here, I'm looking out, I'm looking at the moon, and I cannot see it. This is the new moon phase. It is in syzygy, and at this point, it is in conjunction. And as it's moving, as it's orbiting the Earth, the right side, if I'm looking right here and I look up here, to my right, I'm seeing the right quarter, or this crescent feature of the moon, illuminated. So if I'm standing here looking out at it, I see a waxing crescent. It's waxing because it's gaining illumination on the right side. You're going to hear me use the phrase, the right-hand side is the active side. In this case, if the right-hand side is illuminated, it's waxing. It's gaining illumination. As it continues on, it moves into the first quarter. First quarter moon, half of the moon is illuminated. As it continues moving on, a few days later, waxing gibbous, and eventually, and this is kind of like a 3/4 of the illuminated side, and then back to, over to the full moon side. Notice, the right side is the active side. Here, the right side is being illuminated. It is waxing. Now I'm going to look at the full moon side. I'm going to go from the full moon back to the new moon phase. Remember, the right-hand side is the active side. The full moon side is the side I view from Earth. If I'm standing here looking up, I see the entirety of the moon illuminated. Full moon. A couple days later, it's lost part of its right-hand side due to the darkness. Look at its position in space. Half of the moon is still illuminated, but we are only seeing roughly 3/4. And because it's darkening from the right-hand side, we would say this is waning. The waning phase is losing illumination. A few days after the waning gibbous comes to the third quarter. Notice the right-hand side, it's losing illumination on the right-hand side. So half of it, right, the right-hand side is dark here, whereas in the first quarter, the right-hand side is illuminated. You have to make sure you pay attention to right and left. And a few days later, we have our waning crescent. Our waning crescent phase in this case here. If I'm looking at it from Earth, I'd see that the right-hand side, most of it is dark. Only a little bit of the left-hand side, this sliver, it's called a crescent. Hopefully you've had a crescent roll before. Yummy. And then a few days later, it loses that last little bit of illumination and it goes back to the new moon phase where it starts over. So this is our lunar set of phases. The new moon, waxing crescent, first quarter, waxing gibbous, full. In these cases, in this scenario here, we are gaining illumination. From the full moon, it begins losing illumination, it's waning. Waning gibbous, third quarter, waning crescent, and then back to new moon where it starts over. So let's view that as this animation in this little video clip shows us. So notice the right-hand side, this would be a waning phase. Notice its location relative to the sun. Now it's going to be in the new moon, now it's waxing. Notice its active side is the right-hand side. The sun always lights one half the moon. The moon's appearance changes through the month because different portions of a sunlit half of them are visible from the Earth. For each phase, examine how the view of the Earth is related to the view from space. Notice we're paying attention to the right-hand side. So here it's going through the phases. So I'll start over here. Full moon phase, waning gibbous, third quarter, waning crescent, new, okay, come on, noon, there it is, new moon. Now it's going to be waxing crescent, first quarter, waxing gibbous, and back to full moon. Now I'm going to change this to, so this is a picture of what it looks like, a view from above the Earth's North Pole. So I'm going to change this to an oblique view, right? A side, a kind of an angle view. And we can view this again. Remember, the Earth-Moon system, we have the moon moving as it orbits. We also have the Earth orbiting the sun as well. So we're comparing, or we're viewing the changing way in which we view the illuminated side based on where the moon is relative to the Earth and the sun. So we have to consider all three simultaneously. So here's a page from our binder that we worked on. So let's put times onto where we find lunar phases at the respective zenith. In other words, the highest point. So let's look at this. The new moon reaches its zenith at noon, 12 p.m. Now, even though we can't see it, doesn't mean it isn't there. And the zenith, or the highest point at which a full moon reaches its highest point in the day, remember zenith is the highest point, is 12 a.m., midnight. And therefore, the first quarter moon reaches its zenith at 6 p.m., right? Sunset. And the third quarter moon reaches its zenith, or highest point, at 6 a.m. Now, these are close. They can be plus or minus a few minutes, even up to 15, 20 minutes. But they're close to these times. We're talking about 6-hour intervals of which they reach their highest point. So we have the sun over here. We have the Earth right here. And the moon is what is changing its position. Therefore, we're going to be seeing a different amount of illuminated part of it, which is going to determine its phase. So two very key terms that we have to make sure we pay attention to are what are called synodic and sidereal months. So you may have personally observed that the moon goes through a complete moon phases, or a set of phases, the cycle in about 1 month. And that's true, but that's not exactly 1 month. The synodic period, or sometimes it's called lunation, is exactly 29.530582. Let's call it 29.5 days. It's the time required for the moon to move to the same position or the same phase as seen by an observer on Earth. Now this is very key here. It takes 29.5 days from the lunar cycle from today for it to come back to get back to the same phase as it is today. Remember, this is as we view from Earth. So it's the time required here for the moon to go from phase to the same phase, 29.5 days. However, if you were to view the moon cycling the Earth from outside our solar system, right, our viewpoint is what's called the viewpoint of the stars. The time required is 27.3217 days, right, 27.3 days, roughly 2 days less. This is called the sidereal period, or the orbital period. We're going to call it sidereal. So why is the synodic period different than the sidereal period? Well, the short answer is because on Earth, we are viewing the moon from a moving platform. Very key here. We're moving in our orbit as the moon is orbiting Earth. So during the moon cycle, or the lunar cycle, the Earth has moved approximately 1 month along its year-long orbit around the sun, altering our angle of view with respect to the moon, and thus altering the phase. So the synodic period is 29.5 days. The sidereal month, or sidereal period, is 27.3 days. They're 2 days difference because we're viewing the moon from a moving platform. Very key here. So let's look at that. So the two key terms, Synodic Month, 29.5 days, that's the time to complete all phases as viewed from an Earth observer. Sidereal Month takes 27.3 days. That's the time to complete one orbit viewed from the stars. So let's look at that in this picture up here. So let's go and start off at this picture right here. So we have our direction, our arrow here is going this way. So here it's at the new moon phase. So this picture, these pictures are corresponding to the picture above. So in this case here, we have the new moon phase, right? We have syzygy, we have the sun, we have the moon, we have the earth. And this syzygy feature here would be in conjunction. We have the new moon where we have syzygy at conjunction. However, a couple days later, roughly, it's going to be located right here at this position right here. Here we go, waxing crescent. It's waxing, it's gaining illumination. Remember, half of the moon is illuminated. So we're seeing it, well, we're only seeing a part of that. We're only seeing a sliver or a crescent of it. And then it moves on, keeps on moving a little bit further. A few days later, it moves towards the first quarter where we're viewing half of it illuminated, the right half, that's the active side. Half of it is still dark. Continues moving on. Here we have our waxing gibbous. Here we have our full moon. Full moon is in syzygy. This is where it's in opposition. Here we have our waning gibbous. It's losing illumination, right? It's losing it based on how we see the moon relative to its position to the earth, sun. Here's the third quarter or last quarter. We'll call it third quarter moon. It's pretty much half bisected by the line. Notice the right side is dark. The dark right side is the active side. Here we have our waning crescent, and it's back to the new moon phase. But notice something. Our synodic month is 29.5 days. Remember, we're moving through space as the moon is orbiting the earth. It's had to travel further to get back to the same location as it started, the new moon phase. And in the process of that, see this extra green feature here? That's an extra 2.2 days, right? That's an extra 2 days that it has to travel. Because the earth is moving, we're viewing the phases. As the earth is moving, is orbiting the sun, the moon is orbiting the earth. So why are these months different? Well, they're different because we are viewing the moon from a moving platform. Very key. And this picture really kind of tells it all. So let's go over synodic and sidereal months one more time. So the moon orbits Earth every 27.3 days, but completes a phase cycle every 29.5 days because the position relative to the sun has changed. The moon needs to orbit that much further to return to the same phase. So the moon's phasing cycle is 29.5 days. The word synodic means relative to conjunctions, and those conjunction events being the full and the new moon phase, and that's what we've looked at up to this. So synodic month, by definition, is the period of the illumination phase of the phase cycle of the moon. The cycle of true orbit of the moon is called sidereal month. Sidereal meaning as measured relative to distant stars. So let's look at this one more time. Here's another picture. In the time it goes from this new moon phase here, it has traveled this distance here. So notice, from this new moon phase to this new moon phase, right? The next new moon phase is 29.5 days later. The moon here is one sidereal month is 27.3 days later. So if you look at what we have going on here, the difference of them is that the Earth has moved in space. It has to travel further to get back to this position. That's what this difference right here is what we're seeing. The difference is it has to travel further, and that difference is about 2 days. The difference between the synodic and sidereal. So the sidereal month. So one more time just to kind of recap. Sidereal month, that's the difference between the synodic and sidereal month, stems from the motion of the Earth relative to the sun. Because Earth orbits the sun in 365 days, or pretty close to that, in 29.5 days, from one new moon to the next is one synodic month, right? Phase to phase is synodic, viewed from Earth. Earth moves through an angle of approximately 29 degrees. Thus, the moon must revolve more than 360 degrees between new moons. The sidereal month, which is the time taken for the moon to revolve exactly 360 degrees, relative to the stars, this is about 2 days shorter. Once again, as the Earth is orbiting the sun, the moon is orbiting the Earth, and because the Earth's position has changed in its location, it has to travel an extra distance, and that compensates for the extra 2 days.